Welcome to the Lava2D tutorial on Victor. Lava2D is a depth average flow model designed to simulate lava flows over digital elevation models, or DEMs. It efficiently incorporates variable temperatures for realistic and quick simulations. This tutorial will guide you through the process of running a Lava2D simulation on the Victor platform with a practice workflow. To begin, navigate to the Victor website at victorproject.org. Once you are on the Victor website, click on the Hub portal in the main navigation menu. If you are a new user and have not yet registered, follow the Sign Up link in the main navigation menu and complete the form. If you need further support in registering, please see the Tutorials section of the Victor website under the Education tab. This page includes step-by-step guides under the Getting Started on Victor section and links to the Introduction to Victor YouTube tutorial. Before we begin with the Lava2D workflow, let's ensure the model is in the user's home directory. After logging into Victor, you will see the launcher. Click on the terminal icon at the bottom of your screen to open a new terminal window. In the new terminal window, type Victor Setup and press Enter. Then select Lava2D from the list that appears by entering the corresponding number. This will create a folder called Lava2D in your home directory, which contains the workflow notebook and all relevant files. Before breaking down the details, let's outline the Lava2D simulation process in steps. First, set general parameters. Define the DEM format and path, specify simulation properties, and input ambient temperatures. Then set lava properties. Input properties such as vent temperature, viscosity, crystal percentage, and lava constants. Set rheological properties. Adjust the properties related to crystal packing, yield strength, and more. Set numerical parameters. Adjust values for efficiency, max CFL, and other simulation parameters. Next, specify simulation time. Set maximum time, output times, and simulation intervals. Then, specify eruption timing. Define eruption timing and events for the model. Next, run the simulation. Execute the model by running the cell. Finally, analyze and visualize results. Interpret the simulation results and visualize the lava flow data. Now, let's open the Lava2D notebook by clicking on it. You will see code cells with text written in Markdown included. To run a code cell, click on the play icon or use Shift and Enter. Once a cell finishes executing, the number next to it will advance. If the cell is still running, you will see an asterisk. After importing the necessary libraries, you will choose a digital elevation model to use for your simulation. Ensure to specify the DEM format. Only GeoTIFF files with latitude-longitude georeferencing are valid. And be sure to input the correct path for the DEM. Remember to check the DEM format carefully before inputting, as incorrect formats could result in errors in the simulation. Next, input the vent coordinates by providing the latitude and longitude of the eruption vent. For this tutorial, we will run the model without making changes to the inputs, but you can always make adjustments according to your project's needs. Here, we'll define the properties of the erupting lava at the vent. This includes the temperature of the lava at the vent, lava viscosity, crystal percent, and total volume of the erupted lava. Now, you will enter the constants for the lava. Liquid density, porosity, specific heat, and conductivity will affect how the lava behaves as it flows. Lava emissivity impacts how the lava interacts with the surrounding environment. In this step, input important numerical parameters. These settings control the simulation's computational efficiency and stability, while freezable fraction and minimum thickness are important for simulating the freezing behavior of the lava flow. Finally, the discharge rate represents the rate at which the lava is erupting at the vent. Input the timing and the number of events for the eruption. At least 2 events should be included in the array. Ensure the discharge value in the vent file is accurate and corresponds to the eruption rates. Once all parameters are defined, execute the simulation by running the model. Be aware that depending on the granularity and smoothing of the model, this process may take some time, even up to several hours. After the simulation finishes, you are able to analyze and visualize the results. Choose specific times to review the data. You can plot the simulation output, including the lava flow. Ensure to properly manage and save the simulation results for later analysis. To save your visual output, hold Shift and right-click on the image. Select Save Image As, and choose the destination on your device. By following these steps, you'll be able to effectively run and analyze Lava2D simulations on the Victor platform.